you see, pi is defined as the ratio of the circumference and diameter of a circle. Okay, so they are saying that pi is the ratio of the circumference and diameter, which is true, but this is opposing the fact that we have learned that pi is an irrational number. If pi is an irrational number, then how it can be expressed in rational form? It cannot be expressed in rational form if it is a irrational number. So we have to come to a conclusion that whether it is rational or irrational, we are saying that we have learned that pi is irrational. But now we are getting that pi is in the form of the ratio of the circumference and diameter, which is true. But if it is so, then how come we are saying that it is irrational? So the thing is that, you see, let us draw a circle to understand this. Whenever we draw a circle, okay, this is the center. Whenever we are asked to measure the circumference, which part we measure? This part, right? Not wait. This boundary is known as what? This is known as circumference of the circle. So this boundary is the circumference, right? And what is diameter? The line segment passing through the center of the circle is the diameter. So whenever we will measure this circumference or diameter, we will measure it with a tape or a ruler or any kind of instrument. Let me tell you something interesting. Whenever we will measure the circumference or diameter with any kind of instrument, okay, it will not give us the exact value. We will get the approximate value. Yes, it is right. Whenever you measure any length with any instrument, then you don't get the exact value, you get an approximate value. Okay, that means, so you write the reason. When we measure, okay, one more thing, suppose we got that pi is c by d. Now the measurement of c also we got an approximate value, and d also we got approximate value. Now what is the meaning of approximate value? Approximate means basically a non-terminating decimal. Am I right? It is a non-terminating decimal. That means the decimal will, suppose 1.3 dot 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 1.2 dot dot dot. If like this non-terminating decimals are there, that means you tell me, will their ratio, will it be rational? No, if I get one of them, then also it will be irrational. Since we are getting the approximate values, that is non-terminating decimals, that means this pi is ultimately an irrational number. Okay, so when we measure length with a scale or any other instrument, we get approximate value. This means that either C or D or both are irrational. Therefore, pi is an irrational number. Okay, I hope it is clear. So the next question is question number 5. So what it is saying, rationalize the denominators. That means the denominators are irrational numbers and you have to convert them into rationalized numbers. That means rationalize. Okay, so first question, 1 by root over 7. First you see the denominator is one term or two term. How many term numbers are there? One term, right? Now what we will do, if there is one term, then in order to rationalize it, we will multiply the same term with the denominator, and whatever we have multiplied here, that one we have to multiply with the numerator also. So 1 into root over 7 is what? Root over 7. Root over 7 into root over 7 is root over 7 whole square, right? Now root over 7, then square root and square is gone, then what is your answer? Root over 7 by 7. So we have rationalized the denominator. Next, question number 2. 1 by root over 7 minus root over 6. Now how many terms are there? There are two terms. Whenever there are two terms, you write those two terms, the same two terms, but what you will do, you will write the opposite sign. For example, if there is root over 7 minus root over 6, then you will write root over 7 and root over 6 only, but since it is minus here, it will be plus here, okay? And whatever you have multiplied below, that one you surely have to write with the numerator also. So here 1 into root over 7 plus root over 6 is root over 7 plus root over 6, and here you see a plus b into a minus b. What is the formula? A square minus b square. So root over 7 plus root over 6. You see square and square root is gone. So what is the answer? 7. Again square and square root is gone. 6. 7 minus 6 is 1. So root over 7 plus root over 6 divided by 1. So your answer is root over 7 plus root over 6. Okay. I hope it is clear. Let us move to the next question. 3. 1 by root over 5 plus root over 2. Again two terms. We will write the same terms, but instead of plus we will multiply with a negative sign. So 1 by root over 5 plus root over 2 into root over 5 minus root over 2. And whatever we have multiplied with the denominator, that same thing we have to multiply with the numerator. So root over 5 minus root over 2, and this one you see same terms, a plus b into a minus b, a square minus b square. So root over 5 minus root over 2, and here square and square root is cancelled. So 5 minus 2, root over 5 minus root over 2 divided by 3. Okay. Question number 4. 1 by root over 7 minus 2. Okay. So now you see two terms are there. Same thing. We will multiply the same two terms, just the sign is different. Same thing, whatever we have multiplied with the denominator, we will multiply it with the numerator. So 1 into root over 7 plus 2 is root over 7 plus 2. Same terms. So a plus b, a minus b, a square minus b square. So root over 7 plus 2 by root over 7 square is what? 7 minus 2 square is 4. So root over 7 plus 2 divided by 3. Okay. So I hope it is clear. So let us move to the next question. Number 5. 13 by root over 15. Only one term is there in the denominator. So we will multiply with the same term and no need to worry about the sign. So 13 into root 5 is what? 13 root 5. Root 5 into root 5 is what? Root 5 whole square. So in the numerator we have 13 root 5 and denominator is root 5 square is 5. So we have rationalized the denominator. So next question, 6 plus root 5 by 6 minus root 5. Two terms are there. So we will multiply with the same two terms, 6 root 5, but the here minus is there, so the sign will be plus here, and whatever we have multiplied in the denominator, that same thing will multiply with the numerator. So 6 plus root 5 into 6 plus root 5, you tell me what will be the answer? Same two terms are there, right? So it will be 6 plus root 5 whole square. The only difference between this two and this two is that here the terms are same and the sign is also same. So it is a plus b whole square. But here you see the terms are same but the signs are different. One is plus, one is minus. A plus b into a minus b. What is the formula? A square minus b square. So here a plus b whole square, you apply the formula a square plus twice ab plus b square divided by root over divided by 6 square is what? 36 minus root over 5 and square. So the square root will go, so it will be only 5. 36 plus 12 root 5 plus root over 5 square is 5 divided by 36 minus 5 is 31. So at last we got 36 plus 5 is how much? 41. 41 plus 12 root 5 divided by 31. So this is your answer. Okay. I hope it is clear. So 5 number 7. 5 plus root 3 divided by 3 plus root 6. Same process. Two terms are there. We will write the same terms but opposite sign, right? So 5 plus root 3 divided by 3 plus root 6 into 3 minus root 6. Same terms will multiply here also. So now you see these two terms are not same. So what we'll do? Distributive property, right? First term will multiply with this whole thing and again the second term will multiply with this whole thing. Then next, a plus b into a minus b, a square minus b square. 5 3s are 15 minus 5 into root 6 is what? 5 root 6 plus 3 into root 3 is what? 3 root 3 minus same irrational numbers are multiplying. They both of them are under square root, so they will come under the same square root divided by 3 square is 9, square and square root got cancelled, 6, 15 minus 5 root over 6 plus 3 root over 3 minus root over 18 divided by 3. Now 15, okay, we cannot do anything, these are all okay. Root over 18, can we write root over 18 as 2 9 jana? 9 is 3 square, right? 9 is a perfect square. So if I bring this 3 outside, if I apply square root, then this 3, the square will go and the square root will only remain over this 2. So 18 we can write as 3 root over 2. Okay. So let us write 18 as 3 root over 2. So 15 minus 5 root 6 plus 3 root 3 minus 3 root over 2 divided by 3. So after this you see we cannot proceed any further because all the square roots are different here and we have a rational number and below also rational number and all are different, so we cannot solve it here. Okay. Question number 5, number 8. 2 root 3 minus 3 root 2 divided by 3 root 2 minus or plus 2 root 3. Here you see again two terms are there. So to rationalize it, we will write the same terms, will multiply with the same terms, just the sum will be, just the sign will be different, right? The numerator also will multiply whatever we have multiplied with the denominator. Minus 2 root 3. Now you see this term is same, this term is same. Yes, correct. But if I have to bring it in the formula of a minus b whole square, then I have to arrange it, then again I have to change the sign also. despite of doing all this, if I just apply the distributive property, my answer will come more easily and more quickly, na? So I will apply distributive property here, then answer will come more quickly, despite of doing 3-4 steps of changing the sign, then again arranging it, right? So you apply distributive property in this step. Okay, so 2 root 3 multiplied with this whole thing minus 3 root 2 multiplied with this whole thing. Then in the denominator, a plus b into a minus b, a minus a square minus b square, a plus b into a minus b, a square minus b square. Then now I told you 2x into 3x. Let us take an example. 2x into 3x. First I will multiply the numbers, then I will multiply the variables, right? Similarly here, first I will multiply the rational numbers, then I will multiply the irrational numbers. So 2 into 3 is 6. Root 3 into root 2 is what? Root 6. Minus 2 to the 4. Root 3 into root 3 is root 3 square. Minus 3 3s are 9. Root 2 into root 2 is what? Root 2 square. Minus into minus plus. 3 2s are 6. Root 2 into root 6 is what? Root 6. Then 3 square is 9. Root 2 whole square is what? Root 2 square you can write. Right, it will be 2 only. But for just write for one step. 2 square is 4 into root 3 square. 6 root 6 minus 4 into root 3 square is 3. 9 into root 2 square is 2 plus 6 root 6 divided by 9 into root 2 square is 2. 4 into root 3 square is 3. 6 root 6 plus 6 root 6. It gives us what? I told you, when the root overs are same, they have the same number inside the square root, then we can add the numbers. That means 6 root 6 plus 6 root 6 is what? 12 root 6 minus 4 to the 12 minus 9 to the 18. Again 9 to the 18 minus 4 to the 12. So 12 root 6 minus plus 18 plus 12 is what? 30 divided by 6. Now can we see anything common here? You see 12 and 30 are both multiples of 6. So I can take 6 as common from here. So if I take 6 as common, what I will get? 2 root 6 minus 5. Because 6 2s are 12 and 6 5s are 30, right? 6 we have cut down. So what is the answer? 2 root 6 minus 5 is your answer. Okay. So let us move to the next question. Number 9. So don't be scared by looking at the sum that it is so dangerous. There is nothing like that. You see, this is one term, this is one term. Same thing. Two terms are there. We will write these two terms only. We will multiply with the same terms. Just the sign will change. Okay. So let us do it. Root over a plus x minus root over a minus x, root over a plus x plus root over a minus x. Same terms will multiply, just the sign will be different. Here plus was there, so now here minus is there. So whatever we have multiplied with the denominator, we will multiply it with the numerator. Now you tell me, first term same, second term same, sign also same. A minus b, it will be what? A minus b whole square. So that means root over a plus x minus root over a minus x whole square. A plus b into a minus b. So it will be a square minus b square. Because here terms are same, only sign is different. A plus b into a minus b, a square minus b square. So a minus b whole square, what was the formula? A square minus twice ab plus b square, and in the denominator the square and the square root got cancelled, a plus x minus, here you, since minus is there, you give one bracket, later on we will remove the bracket, square and square root got cancelled, a minus x. So again you do the square root of this, square and square root will get cancelled, a plus x minus, I told you when two numbers are there that have square root and they are multiplying, they will come under the same square root and get multiplied, and here a minus x divided by a plus x minus a, minus into minus plus, right, plus a minus a got cancelled, a plus x minus 2 into this one, you see the terms are same, a plus b, a minus b, a plus x, a minus x, a square minus b square plus a minus x divided by, here what we got, twice x, x plus x is twice x, plus x minus x got cancelled, right? So what you have got here, okay, let me write here because the space is less, a plus a, what we got, twice a minus twice of root over a square minus x square divided by, in the denominator I got twice x. Here can I get anything common? Yes, I can take 2 as common, a minus root over a square minus x square divided by 2x. 2 and 2 got cancelled, so we are left with this answer, a minus root over a square minus x square divided by x. Okay, I hope it is clear. So number 6, number 1, what is given? The value of x is given, x is equal to 1 plus root 2, and we have to show that x minus 1 by x whole cube is equal to 8. Okay, so first you write whatever is given. What is given? X is equal to 1 plus root 2. Now in order to show something, usually what we take left hand side, right hand side. Since the right hand side is 8 here, so this one we already we cannot solve it, right? So what we have to try to solve the left hand side, right? So we'll take the left hand side, x minus 1 by x whole cube. So here what we can write, 1 plus root 2 divided by 1 plus, here you see this is also x, so we wrote the value 1 by, again here also x is there, na? So we wrote the value 1 plus root 2 whole cube. Now nothing is there means 1 is there, right? Can I take the LCM of these two terms? Because anything if I do the LCM with 1, I will get this term only, na? 1 plus root 2 whole cube. Then 1, how much is this much? 1 plus root 2 only. So here already 1 plus root 2 is present. So it will be 1 plus root 2 whole square. And 1 plus root 2, how much is 1 plus root 2? 1 ja. So here 1 into 1, right? So 1 plus root 2 whole square, a plus b whole square. What is the formula? A square plus twice ab plus b square minus 1 divided by 1 plus root 2 whole cube. Then 1 plus 2 into root 2 is what? 2 root 2 plus root 2 square is what? 2 minus 1 divided by 1 plus root 2 cube whole cube. Then plus 1 minus 1 got cancelled. Now can we see anything common here? Yes, 2 is common, right? So if I take 2 as common, then what I will get? Root 2 plus 1 divided by 1 plus root 2. You tell me, root 2 plus 1, 1 plus root 2 are same or not? A plus b, b plus a, same thing, na? If it is minus, then it is different. But since positive are there, a plus b, b plus a, same thing. So these two are cancelled. So what we are left? 2 cube. 2 cube is what? 8. So left hand side is equal to right hand side, which is shown. Okay, I hope it is clear. Let us move to the next question. So 6 number 2 we have to simplify. You see all of them we have irrational numbers in the denominator. So if I take LCM also, it will be very difficult for me to solve. It will take a long procedure, right? So what I'll do, I will take each fraction and I will rationalize it. I will rationalize the denominator, right? So I will start with the first fraction, 1 divided by 1 plus root 2. What I will multiply? 1 minus root 2. In the numerator also 1 minus root 2. And here the second one you see, root 2 plus root 3. What I will multiply? Root 2 minus root 3. And in the numerator also same thing. Then the third fraction I will rationalize it to. So root 3 plus root 4. What I will make it? Root 3 minus root 4, and here root 3 minus root 4. Okay. So 1 into 1 minus root 2. What I will get? 1 minus root 2 only. A plus b, a minus b. A square minus b square. Then 1 into root 2 minus root 3 is root 2 minus root 3 only. Here a square minus b square, right? Then here 1 into this thing is this one only, root 3 minus root 4. Again here root 3 square minus root 4 square, because why? A plus b into a minus b, a square minus b square. Now 1 minus root 2 divided by 1 minus root 2 square is what? 2 plus root 2 minus root 3 divided by root 2 square is 2, root 3 square is 3 plus root 3 minus root 4. Root 3 square is what? 3, root 4 square is 4. Now 2 minus 1 is 1, but since bigger number has minus sign, so minus 1 plus root 2 minus root 3. 3 minus 2 is again 1, bigger number minus sign, so we'll give a bracket here because plus and minus we never write it together. Plus root 3 minus root 4. 4 minus 3 is 1 minus 1, again we'll give a bracket. Now if I take this minus, because 1 is in a denominator and it has no value, so ultimately I have to bring the minus in the numerator. So if I bring the minus with the numerator, then the minus will get multiplied here, right? So I have brought the minus in the numerator. Again here you see, when I'll open this bracket, then plus and minus will multiply, plus into minus is minus, and here root 2 minus root 3, and here again plus into minus is minus, root over 3 minus root over 4. Then you open these brackets. Now we have just multiplied these signs. Now we have also opened the brackets and multiplied this minus sign with these terms, right? Minus, minus into minus, plus, minus root 2, minus into minus, plus, root 3, minus root 3, minus into minus, plus, root 4. Plus root 3, minus root 3 cancel, plus root 2, minus root 2 cancel, minus 1. Root over 4, can we write root over 4 as 2 square? Square and square root got cancel, what we are left? Minus 1 plus 2. 2 minus 1 is what? 1. Bigger number, the sign is plus, so what is the answer? 1. So 1 is your answer. Okay. So 6 number 3, add the rational numbers 1.27 bar and 0.13 bar. So you first see 1.27 bar, what I can write? 1.2, since 7 is repeating, that means 7 7 7 dot dot dot, right? It will go on. Next 0.13 bar, what I can write? 0.1, after the 3 is repeating, dot dot dot, right? Now we have to add them, right? Now you see, if I take, suppose I cannot write, keep on writing forever, right? I just need to write few of them. If I suppose write up to 4 places, and here also, then you see 7 plus 3 is 10, 7 plus 3 10, 11, 11, 11, 2, 3, 4, 1.4, 1, 1, 1. Okay. Now you can tell me, sir, this 1 is repeating 3 times, but 0 is repeating, means continuously repeating. That means the bar will come in this 0? No. The bar will come above this 1. Why? Because suppose if I have written again few more 7s and few more 3s, then when we will add them, we always have to consider 1, 0, then we will give 1. Now that means 0 was never repeating, because this is a non-terminating decimal, it will go up to infinity. Whenever we have to consider 7 and 3, then also we have to consider that one more 7 and 3 is there after that. So from there we'll get a 0, after that we'll always get a 1. So that means the digit 1 is always repeating. Is it clear? So that means 1.277 dot 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 plus 0.133 dot 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 will give us 0.1141 dot dot dot, that means 0.141 bar. Okay.